Okay, we've all been there, right? You get that frantic call from a user, there's a deadline looming, and you hear those dreaded words, I can't get online. But what if I told you that most of the time, the problem isn't the entire internet? It's usually something much, much closer to home. Today, we're going to dive right into the essentials of networking and cloud troubleshooting, and we're going to solve this exact problem once and for all. So this is it. This is the kind of call that can make any IT support pro's heart just skip a beat. But before we even think about panicking, let's just take a breath. You know, the internet itself almost never goes down for just one person. And that simple fact, that's our first clue. And believe me, it's a big one. The problem is almost certainly local, and that's exactly where our investigation is going to start. Now, the first instinct here is to just start guessing, right? Did you try rebooting the router? Is the cable plugged in? Maybe it's the Wi-Fi. But look, trying to fix a network problem without a plan is like trying to find one specific book in a giant library without a catalog. Yeah, you might get lucky, but you're way more likely to just waste a ton of time and get super frustrated. That's why we're going to use a proven method to guide us through this maze. And here it is. This is our roadmap. This isn't just some boring list. It's a really powerful framework. First, we identify the actual problem by gathering facts, not feelings. Then, we establish a theory, basically an educated guess about what's causing it. Next, we test that theory to see if we're on the right track. If we are, great. We create a plan and implement the fix. After that, we verify that everything is working perfectly. And finally, and this part is absolutely crucial, we document everything so we can learn from it and help the next person even faster. Okay, so where do we start? The user's computer is ground zero. It's the epicenter of the problem, so that's the most logical place to begin. By looking at its network settings, we're basically getting a snapshot of how the computer is trying to talk to the network. Think of this as the crime scene. This is where we're going to find our first and probably most important clues. At first glance, I know these numbers might just look like a random jumble of digits, but to a trained eye, they tell a story. And in this case, the story is about a computer that is completely lost and has no idea how to find its way to the internet. The problem is literally hiding in plain sight. Can you spot it? But hang on. Before we solve our current mystery, let's talk about a classic red flag. What if you looked at the user's settings and saw an IP address that started with 169.254? If you feel a little jolt of panic when you see that, you're on the right track. That number is a huge signal that something is seriously wrong with the connection to the network itself. That's what we call an APIPA address. So imagine your computer needs a phone number from the network's phone book. That's the DHCP server. But for whatever reason, the phone book isn't answering. So what does your computer do? It just makes up its own number. The problem is, this number isn't listed anywhere, so nobody on the network can call it. In the real world, this could mean a bad router, a disconnected cable, or maybe the office's main DHCP server is just down. Okay, let's get back to our user's actual settings. The problem isn't as obvious as one of those APIPA addresses, but it's just as critical. Here's a hint for you. Look at the relationship between the IP address and the default gateway. Do they look like they belong on the same team? And there it is. The IP address is 192.168.10.5, but the gateway is 192.168.1.1. That subnet mask, the 255.255.255.0, is what tells the computer that its street name is the first three numbers. So our computer is on 192.168.10 street, but its door to the internet is all the way over on 192.168.1 street. It's like living at 123 Main Street, but your mailbox is on Elm Street. Nothing's ever going to get through. Let's just make this crystal clear. The default gateway is basically the front door of your house. If you want to go outside to the rest of the world, the internet, you have to go through that front door. And just like your front door has to be attached to your house, the default gateway absolutely must be on the same network, the same street as your computer. Okay, so we've found a very likely culprit, but a great troubleshooter always considers all the angles. So let's explore another really common issue that can cause almost the exact same symptoms: Wi-Fi problems. I mean, even if your IP settings are perfect, a weak or unstable wireless connection can bring all your productivity to a screeching halt. So, welcome to the wonderful world of Wi-Fi standards. This might look like a bunch of alphabet soup, I get it, but each of these represents a different generation of wireless tech. And just like with smartphones, the newer generations like Wi-Fi 5 and especially Wi-Fi 6 are way faster, more efficient, and much better at handling lots of devices at once, which is super critical in a busy office. And these standards operate on different radio frequencies. So here's the practical takeaway. If you're in a crowded office, or maybe an apartment building with tons of other networks around, you'll probably want to use the 5 GHz band to avoid all that interference and get faster speeds. But if you're in a large space with thick walls, that 2.4 GHz band might actually give you better, more reliable coverage. It's all about choosing the right tool for the job. Okay, so our IP is correct, and our Wi-Fi signal is 5 bars. We can still run into problems. Why? Because our data has to get to the right door. Imagine a huge apartment building. The building's street address is the IP address. But to visit your friend, you also need their specific apartment number, right? Well, network ports are just like that. They're the apartment numbers for every single service on a computer. So when you send an email, your computer doesn't just send it to the mail server's IP address. No, it sends it to that IP address and a specific port for email. This tells the server, hey, this data is an email, it's not a web page request. If a firewall is blocking that specific port, that door, your email is never going to get delivered, even if you have a perfect connection. This slide right here, this is your new best friend. Seriously, if you're serious about a career in IT support, you need to know these port numbers like the back of your hand. They are the keys to diagnosing so many of those "why can't I connect to X" problems. Memorize them. They will make you look like a troubleshooting wizard. So far, we've focused pretty much entirely on the user side of the connection. But what about the other end? Where do all these websites and email servers we're trying to reach through these ports actually live? In today's world, the answer is almost always the same. They live in the cloud. But the cloud isn't some magical, fluffy thing up in the sky. It's a physical network of millions and millions of servers housed in massive, super secure data centers that are owned and operated by companies like Amazon, Microsoft, and Google. When you use a cloud service, you're really just renting a small piece of this incredible global infrastructure. So, if your company is thinking about moving to the cloud, which kind is right for you? Well, there are pretty much 3 main flavors to choose from. Public, where you rent space from a big provider. Private, where you build and own your own. And hybrid, where you use a strategic mix of both. Each one has its own pros and cons, so it's a really critical choice. And here are those trade-offs. Public clouds are amazing for flexibility and cost, which is perfect for a startup that needs to scale up really quickly. But you do give up some control. Private clouds, on the other hand, offer a maximum security and control, which is why banks and governments love them, but they are incredibly expensive to build and maintain. The real key is finding the right balance for your needs. All right, we've examined the clues on the PC, we've cleared the wireless air, and we've even located our destination in the cloud. We've gathered all the evidence. Now it's time to solve the case. Let's go back to our original problem and put all these pieces together. And the culprit, just as we suspected from the very beginning, was that misconfigured default gateway. The fix is actually beautifully simple. We just need to change that gateway address so it's on the same street as the computer. Once we set it to something like 192.168.10.1, the computer can finally find its way to the internet, and our user is back in business. But wait, we're not done yet. Before we declare victory, we have to verify the fix. And the best way to do that is with a good old-fashioned ping test. It's kind of like sending a scout out to see if the coast is clear. We ping our new gateway first. If that scout comes back, awesome. Then we ping the internet. Something like 8.8.8.8 is a great choice. If that scout comes back, we know we're good to go. The ticket is closed, the user is happy, you're the hero of the day. But your job still isn't quite over yet. There's one final step that separates the good technicians from the truly great ones, and that's documenting what you did and why. Your notes today could be the key that saves your teammate hours of work tomorrow. Don't just fix problems, make the whole team smarter. That's how you become absolutely indispensable.